there's a zone where suddenly the computer model starts producing behaviors and actual geometric forms that look like living things. And this turned out to be the realm of complexity. It's an information-rich zone. It's the zone where life arises out of all the other elements that exist in the world. It's self-sustaining. It's adaptive. So if the environment around it changes, it finds new ways to change. And it does that by always having a little bit of randomness in the system, so it can try out new possibilities. So an example that's very common for people to use are ant colonies, because everyone knows ants. You grow up, any kid who's grown up anywhere in the world has seen ants, either inappropriately crawling in your house or out in the yard. And ant colonies are very complex, but well-ordered communities. They form food lines, they have storage areas, they have cemeteries where they take the bodies of dead ants from the colony. Some types of ants will actually farm and grow plants or fungus, and they'll have like a farm that's well ordered. And there's no ant in the colony that's organizing this. The queen ant it's not a top-down order. She just serves a reproductive function. This is all bottom-up interactions, the ants signaling each other through contact or through sensing each other's pheromone scents. They have 9 different scents that they can lay down. And out of these local interactions between each other, they form all these elaborate structures. The thing is, it's not 100% certain. It's not 100% machine-like. So there's always a little bit of randomness in the system, which you need, because if the environment changes, if the ants were totally well adapted to that particular environment, the food is over here as opposed to over there, then when the food runs out, they'd have no ability to find new food. So for example, when you have a food line, straight line of ants going from a bit of food over here to the colony over here, going back and forth, there's always a few % of the ants that aren't following the food line. Those ants are going to be the ones that if you put your foot down in the middle of the food line, those divergent ants are going to be the ones that very rapidly find the new route that's quickest around your foot, or your hand in this case. Or if the food source runs out, it's one of those ants not in the line that's already going to hopefully randomly bump into some food and then begin to establish the new food line, so that when this runs out, this one takes over. If there's too much randomness in the system, no ant winds up following a line. So too much randomness is no good. But if there's too little randomness, there can't be a change in behavior if the environment shifts. And then things collapse because there's no adaptation. So there needs to be this little tiny zone of limited randomness that's completely unpredictable. And that randomness in that mathematical zone between order and chaos is what allows life to happen, what allows adaptation and evolution and creativity to happen.
That's why knowledge matters.